Welcome back. Now we're going to take a look at Chapter 2.2, Physical Properties. This may seem new, but when you get into it, you're going to figure out you've already done it before. I think most of you have had the experience either last year or in previous years of figuring out what a giant pile of minerals were by using the characteristics like hardness and whether or not it was magnetic and what color streak it made and whether or not it reacted with an acid and whether or not it was harder than a penny. And these are all characteristics that you used to figure out what the minerals were. These things were all physical properties. We're going to take a look at some others. The first one we're going to look at is viscosity. Viscosity is the resistance to flow. Things that are more viscous move slower, and they have more viscosity. My mom used to tell me that I would move slower than molasses in January. That's because many liquids become less viscous when they're heated and more viscous when they're cooled. If you've ever tried to pour molasses, you know that it moves very slowly. So molasses in January barely moves at all. When a frustrated mom is trying to get out the door, molasses in January is not the speed she wants her children to move. So, viscosity. Conductivity. You already know what conductors are. We already talked about metals. Metals conduct electricity. You figured that out in the electricity unit. But metals also conduct heat. A measure of how well a material transfers heat is conductivity. Those materials will also often transfer electricity at the same rate. Things that are not good conductors are things like wood and plastic. Things that are good conductors are things like metal. The inside of this tomato, the liquids in there, are actually good conductors, and you can see that the electricity flows through and is measurable on the meter. Malleability. The ability to be hammered without shattering. Metals are very malleable. That's why they get hammered into sword shapes and knives. Ice, not very malleable. When you hammer it, it shatters and breaks. Glass, don't even try and hit it with a hammer. Not malleable. The hardness scale. You already saw Mohs hardness scale. You know the diamond is the hardest material that we know about, and if we want to cut diamond, we have to use diamond. We also use diamonds in many industrial blades. Talc is so soft that we used to use it on babies' bottoms. We don't anymore because we found out it's maybe not so good for our lungs, but we still use it in industrial applications where we need things to be slick. Gypsum, calcite, fluorspar, I think it should be fluorine, apatite, feldspar, quartz, topaz, and corundum are all examples of things on the hardness scale. Corundum, sapphires and rubies. Harder materials will scratch the other materials. Melting point and boiling point. If you want to go from a solid to a liquid, you have to go through the melting point. If you want to go from a liquid to a gas, you have to go through the boiling point. For water, that melting point is about 0 degrees Celsius, and that boiling point is about 100 degrees Celsius. But for every individual material, that temperature is going to be a little bit different. Mercury is one of the only metals that we see liquid. We see it liquid at room temperature. Unfortunately, it's too dangerous to play with, so we don't see it very often anymore. And we all know how much I love density. It is a way to test the purity of a substance or to identify a substance. We can identify how pure it is by how close it is to the number that we expect it to be. We can also use it to identify a substance. I bet you if I gave you a whole pile of candy and you couldn't see it, but I could give you the density, you could pick out which ones the starbursts were. In an old story, Archimedes used a system with a gold crown to figure out whether or not the king had been gypped, been taken, by figuring out whether or not all of the gold that the king gave the crown maker was actually in the crown. The crowns don't have a very good shape to do math, but they were able to get the volume and they were able to get the mass, and then they could get the density, and they could figure out whether or not the king had been cheated. Why do we care? Well, you can use properties to help you choose a material. Whoever designed this baking rack, obviously not a good plan for something that's going to go in the oven. It didn't survive very well. Likewise, you can use properties to determine if you are going to buy a good material or if it's going to be what you are hoping you get. If somebody comes up to you and offers you a really cheap gold necklace and it only has a density of 5.9 grams per cubic centimeter, you should just walk away. So, in the end, you've already been using properties. You know what they are. They're anything that we can see or measure or observe and document to prove that something is or isn't. You could also use taste and odor as properties as well. So pause this where you need to, fill out your notes, and we'll see you next chapter.